Hello, in this episode, we'll discuss about various definitions of accuracy, like precision, recall, F1 score, ROC, AUC, what are they? So oftentimes a task in machine learning is to separate the guilty from the innocent. So in this picture, for example, the black dots are the guilty ones and the hollow circles are the innocent ones. And suppose that our model is like a circle. So within this circle, we accuse them to be guilty. Some of them are truly positive, like here in the circle, but some of them are falsely accused. These are we call false positive. Outside these circles, for the truly guilty ones, it's missing of being guilty, so it's false negative. And outside the circles are truly negative, what we oftentimes, we also use these, separate them as a confusion matrix and then sort them. So here we have the reality of guilty and innocent, positive or negative, and the predicted, our model predicts negative or positive. So when it's actually guilty and we accuse them, it's truly positive, it's correctly accused. And it's truly negative and we don't accuse them, it's truly negative, that's also the correct one. But sometimes we make error, the model makes error. Like the truly innocent one tagged as guilty, accused as guilty, which we call type 1 error, which is false positive. The opposite case is when it's truly guilty, but we miss it, the model misses it, it's type 2 error, which we call false negative, isn't it? The type 1 error is a more serious error in that you're accusing an innocent one. That's why we call type 1 error. There are some definitions according to these fractions. The precision is among the ones that we accuse as guilty, how much actually are truly guilty. And there's a recall, which is among the truly guilty ones, how much are actually truly guilty. So remember this definition. So there's a trade-off between precision and recall. That's why we need both of them. For example, if we identify a single individual as guilty, so we got lucky and we pick the first one and the one happens to be guilty. Let's just stop there. The precision is 1. You accuse one person and that one person is guilty. So the ratio of the precision is 1. Is that a fair thing, a great thing? No, because if you look at the recall, there are many, many guilty and you just tag one. So the ratio looks bad. So recall will catch this pitfall. On the opposite hand, if you accuse everyone, okay, then your recall is a 1, isn't it? You accused everyone, you certainly catch all the bad ones. But the precision is low because you also accuse a lot of innocent ones, isn't it? So the precision catches that kind of pitfall. And if we label no one as guilty, it has 0 precision and 0 recall. And to combine these two measures, sometimes we use what we call F1 score, which is a harmonic mean of the precision and recall. The formula is 2 times precision times recall divided by precision plus recall. Again, harmonic mean. To visualize this accuracy, oftentimes people use a receiver operating characteristics curve, which is a plot of the false positive rate and true positive rate. The false positive rate is the false positive among the innocent ones, how much you falsely accuse. So you want that number to be small, isn't it? So fraction of falsely labeled as guilty among truly innocent. And if we label everyone guilty, for example, this becomes 1 terrible thing. All innocent get falsely labeled as guilty. And as your threshold increases, meaning you accuse fewer people, you put a higher bar, then the fraction of falsely labeled as guilty will decrease, isn't it? So it will decrease like this. The true positive rate is the fraction of correctly labeled as guilty among the all truly guilty, isn't it? So how much are you accusing to be guilty and among all the guilty? So you want that number to be high, isn't it? If the label everyone guilty, it becomes 1. All guilty gets correctly labeled as guilty. As the threshold increases, if you put tougher bar, you will unfortunately miss some of the guilty ones, isn't it? So ideally speaking, you want this to be as the threshold from this very low bar, accuse everyone, to accuse very, very few ones here. The false positive rate drops, and your model, if they tend to accuse the guilty ones much more than the false ones. Then as your threshold increases, you accuse fewer people, it will drop the innocent people and your false positive rate drops. But at some point, because the bar is so high, you cannot accuse anyone, your true positive rate will also drop. So ideally, this is what will happen. If your model is not skillful, it drops the innocent and guilty at the equal rate, then it will follow along this 45-degree line. Okay. In reality, an able model, it follows like a green line here. As the threshold increases and accuse fewer people, the false positive rate drop will much faster than the drop in the true positive rate. But at some point, true positive rate will also precipitate, right? Okay. So how close is this green line to this red line is for the performance. You want this to be as close as to this red line. And a measure of this is what we call area under the curve, AUC, which is the area under, let's say if your green line is a model, the area under this green line. This ranges between 0.5, typically a random guess, to 1, isn't it? You could, of course, go below 0.5 if your model is actually too dark. Okay, so let's see how it works in a program. Okay. So let's go to Google Colab. Okay. So here some import some libraries, and scikit-learn is mainly what we rely on. So here are all kinds of libraries that we use: RSA curve, precision, recall. These are all pre-computed. There are packages for that, so you just have to call them, isn't it? So let's just generate 2 classes. I'm just generating 2,000 examples and 2 classes, and randomly state. Okay. And check the dimension of the data of the innocent and guilty. So, so there are 2,000 points, and there are 20 characteristics, and the label of guilty and innocent. Let's split them into train and test set. Split them X and Y, the label and characteristics. So and let's generate no skill prediction, meaning just a random number. So it's like a 50-50, like a coin toss. And here we'll just be simple and just have a logistic regression as the classifier. So we fit the model using the X-train, the characteristics of that sample we created, and the label of innocent and guilty. And here's the predicted probability. Hopefully the logit is informative, it's a skillful, so it will detect more guilty than the innocent ones. So let's keep the probability of being positive. So the logit will produce a column for detecting the innocent and a column for detecting the guilty. The second column, the column indexed at 1, because 0 is the innocent, 1 is the guilty, so we keep the column 1. So what's the ROC curve? The no skill area under the curve, AUC score, and the logit of this. So we make a comparison. The AUC of the no skill, the random number generated prediction of tagging guilty, it's 0.5, as said. And the logistic of the logistic model is 96.6%, which is pretty good. So AUC, you can see, is a measure of this curve. And now calculate the ROC curve, the false positive rate, and true positive rate, okay, to draw an ROC curve. And then we can plot them, isn't it? So you can plot the true positive and false positive rates and the random. So here's the random curve, the no skill, and here's the logit model's true positive and false positive rate. Now, another definition is precision and recall. So let's have a prediction, like having in the test data predict and then call it y hat. Okay, and let's have precision recall and have from the logit. Okay, and F1 and AUC, F1 score. So the logit model have an F1 score of 92% in a test data. It's lower than the training situation because it's an on-scene data. The area on the curve is pretty good, it's 97%. So actually the larger model is doing pretty good. And you can also plot the no skill and logistic models, recall and precision. Okay, and here we go. Okay, so when you have very high recall, you have low precision, and as the recall drops, the precision increases. But probably here somewhere is probably an optimal point where it actually has a reasonably high recall and high precision. So you want to probably somewhere in this. So this is how in Python you can use all these scikit-learn packages to help you measure of accuracy. Thank you for watching this episode.